Hello, so we all know the difference between a line graph and a bar graph, but do we all know when we need to use one rather than the other? My experience says that we don't. So I'm going to give you a quick lesson on how to determine which graph is correct for the data that you have. The answer lies in whether the data is discrete or continuous. Discrete data is data which has defined units and must therefore be a bar graph, while continuous data is numerical data which lies on a continuum and therefore must be a line graph. Now that's still confusing, so we'll have a look at a few examples. A baker counts the number of rolls he sells each day and records his data below. So you've got your information there. The independent variable is the day of the week. That's what's changing, and the dependent variable is the number of rolls sold, and that's what we're counting. So which type of graph is it? Well, you can see here that it is a bar graph. You've got to look to the independent variable to find that. Put simply, you are counting the rolls sold on either Monday or on Tuesday or on Wednesday, etc. There is no Monday and a half or Tuesday 0.5. The independent variable is set in defined units, and that tells us that it's going to be a bar graph. The same could be said for rolling a dice. So we've rolled a dice 20 times, and we've counted how many times it's landed on each side. The independent variable is the side of the dice, and the dependent variable is the number of times rolled. So, I can only roll a 1 or a 2 or a 3. I cannot roll a 1.5 or a 2.5 or a 3.5. This means the data is discrete, and therefore it will be a bar graph. So continuous data now. Continuous data has an infinite number of midway points between one independent variable point and the next. So it should usually be used when the independent is time or distance or mass, etc. In this example, I'm measuring the change in temperature of water as it heats over a time period. You can see my results are recorded. The independent variable is the time. The dependent variable is the temperature. When it goes and is put into its line graph, we can see our independent variable points here are time in minutes. Now, in this case, there are points in time between 1 minute and 2 minutes. There is 1 minute and 30 seconds, 1 minute and 45 seconds. In fact, an infinite number of periods between 1 and 2, and same again between 2 and 3. Using a line graph, we can now estimate what temperature the water would be after it's been heated for 1.5 minutes, or 2.5 minutes, or 3 minutes and 10 seconds, whatever time period you would like to use along that continuum. For our second example, for continuous data, we are going to measure how fast a car is going at different points in time. The independent variable is time, and the dependent variable that we are measuring is the speed. Again, this goes into a line graph. Similar to the previous example, we look to our independent variable, and we can see that between 1 second and 2 seconds, there is infinite number of time periods. Between 2 and 3, 3 and 4, etc., there are time periods. So whether that's 1 to 1.5 to 2, or 1 to 1.1 to 1.2, all the way through, is irrelevant, but we do know that there are time periods between one point and the next. By using the line graph, again, we can estimate how fast the car is going at any one of those infinite number of points along that time continuum. Hopefully, using this tutorial, you'll be able to better understand when you are to use a bar graph or a line graph for the data that you have collected.